All right, number 33, give the domain and range for the rational function, use interval notation, and we've been given f of x equals 7 over x. All right, so we're talking about domain and range. Let's first quickly review what domain and range are, right? We recall that domain refers to the permissible values of x that we can use in this function, and the range refers to the permissible y values that we can use in this function. And generally speaking, finding the domain for some function is easier than finding the range, because when you're finding the domain, all we're going to be dealing with in a rational function is the denominator, because we know when we're dealing with a fraction, right, 7 over x is a fraction, the only x value, the only number that we cannot allow to be in the denominator is what? 0, right? We cannot have a 0 in the denominator. So when you have a rational function like this, take the denominator of the expression on, in this case, the right-hand side of the equal sign, take whatever that denominator is, and we're saying, in this case, x cannot equal 0. Now, with 33, it's nice because there's not really anything to do here, because this was only an x in the bottom. So when we say that x cannot equal 0, we're done. We didn't really have anything to solve. So what this is telling us is that x can be any real number in the world, except we cannot allow x to be 0, because when we allow x to be 0, plug it in, well, we get undefined, don't we? We can't have a 0 in the denominator. So if we're asked, and in this case we are, to write in interval notation, then we can say that the domain, the x values that are permissible, are everything from negative infinity up to 0, but not including 0, and then union, and then again from 0 out to positive infinity. So there's our set notation, our interval notation that expresses what are the permissible values of x, our domain. All right, now let's talk about range, the permissible y values. Now, there are a couple different ways that you can find the range for a rational function. We can find it graphically, which is nice. Sometimes, though, graphing calculators can be difficult to read, right? Because we're looking for fine detail, and sometimes, depending on what model you're using, sometimes the screens aren't very clear. So let's go ahead, instead of using our calculator to initially find what our range is, and we'll confirm later at the end here what the range is using the calculator, but let's go ahead and just find what the range is analytically. So if we were given f of x equals 7 over x, I'm going to rewrite that as y equals 7 over x. And now what I want to do is, notice how we have y solved for. What I want to do to find the range is solve for x, meaning let's get x all by itself. And to do that, we're going to multiply by x on both sides, right? Because here on the right, they will cancel. And now that leaves us xy equals 7. And then if I want x all by itself, then all I have to do is divide by y on both sides, and that gives us x equals 7 over y. And now that I've got x all by itself, what I can do is ask a similar question that I asked up here with the domain. But notice now that we're talking about the range, right? So that's why we have x solved for, because we're trying to find out what are the permissible values of y. Well, in this case, just like before, we don't want to have a 0 in the denominator, right? And so in this case, we're going to take whatever is in the denominator, and we're going to say that denominator cannot equal 0. And just like before with x, all of our work is done. We didn't really have anything to solve here, because what this is telling us is that y can be any number in the world except, again, 0. All right, so how would we write that in interval notation? Well, just like we did with the domain, we're saying that the range, the y values, can be anything from negative infinity to 0, but not including 0, union, and then from 0 out to infinity. All right, so again, to find range, in this case, all we did is we solved for x in the given function, in the given equation, and then we asked a similar question. All right, well, now that we have x equals 7 over y, what are the only values that y cannot equal in this equation? And y could not equal 0, otherwise we would have undefined here. And so that tells us that the range is negative infinity to positive infinity, except at y equals 0. But let's confirm that on our graphing calculator. So we're going to go to our y equals screen, and we'll plug in 7 over x. So 7 divided by x. We want a standard zoom window, so let's see what we have here. All right, and there it is. And we can see that we have two asymptotes here, right? We have a horizontal asymptote and a vertical asymptote. So our horizontal asymptote is right at y equals 0, and that's why we found that y couldn't be 0. Y can be anything else except 0, because there's a horizontal asymptote there. And again, we found that the vertical asymptote tells us that x cannot be 0. And so that's why the domain was everything from negative infinity to positive infinity, except right at that asymptote y equals 0. So again, it's always nice to confirm using the graphing calculator, but I would recommend trying to analytically find what your domain and range are, and then use the calculator to confirm. All right, there's number 33. Let's take a look at number 34.